All right, this is the, excuse me, this is the MSI automation magnetic hypothermia system. This is the new unit. You have your on button, off button, your power control. You have your temperature controller. You have bar graph indicating power and frequency. And you have your touch screen. So what you do is you have the key in here. Make sure your key's there, and you push the green button. And you get a light here indicating you have 24 volts. The 24 volts runs the touchscreen. You have several screens here. This is your main screen. And the button on the left, in order to begin heating, you have to push it once. Manual. Manual mode means you can control the heating power here. Remote means if you have, if you're connected to the rear of the unit with a cable, you can control the power on, off, and also the power regulation up and down from a remote location. But we're not set up for that right now. It's a possibility, but I didn't provide it because it wasn't in the purchase order. So we'll go back to manual mode. Again, here's your power. So to first review, we have a warning up here. It says water flow and it says heat off. Okay, so we don't have any water pressure. Typically I run about 20 psi and it's marked on the gauge on the back. So I'll turn the water on. Now it says system okay, heat is off. Now if you want to heat, before you start heating, let's see what we got. We have a 100 millimeter coil there. For the 100 millimeter coil, I like to use frequency 2, and then there's a frequency 1 for the smaller coil, this 60 millimeter. But we'll use frequency 2. Also have auxiliary button. Don't use it. It's not connected to anything. Then we have what we call the X factor. And this is your screen for, sorry. This is your screen for measuring the magnetic field with this probe. But we'll come back to that in a minute. So let's go back to the main screen. Also you have manual heating or timed heating. Right now I set it for 15 seconds. The timer starts when you push the button. But for the large coils, like the 100 millimeter, it takes about 7 seconds for it to start really heating. So this first 7 seconds, you're not going to be heating anything. So take that into consideration. There's also in the timer mode, you have on time, off time, and the number of cycles. You can change those cycles to 1, 2, 3, or 4. Let's say you want, I mean, the off time now is not relevant because we're only using 1 cycle. But anytime you want to change it, you enter it. All right, we're just going to, the timer is not that important, so we will concentrate on the heating from manual mode. So to start, what you notice is we start at a high frequency and we start sweeping down. Let me zoom in. When you start heating, you start at a high frequency and you search for the resonant frequency. In this case, it's 180 kilohertz. And then as soon as it gets to the resonant frequency, it locks, and it's called frequency lock. So now we're at resonant frequency. And you can control your power up and down, just like this. Now you hear that click? I'll tell you about that later. That's a relay. Then to turn it off, you just push the button. I flipped the circuit breaker on the back down. I wanted to show you something. All right, now we have a temperature controller, and I did program it so it matches the fiber optic temperature. Right now the fiber optic's not attached, so it doesn't know what to do. It's confused. One thing you have to understand about the temperature controller, it doesn't really control the power up and down, okay? You would set the PV value, present value, you set that for whatever maximum temperature you want. And then the controller will turn on the heating power and try to reach that temperature. And as it approaches the temperature, it starts to reduce the power, and ultimately it tries to maintain that target temperature. We'll call it a target temperature, okay? So even though you set this for 40 degrees centigrade, 40 degrees C, it's up to the machine to try to get to that level. All right. So that's one thing. There's a number of things I have to talk to you about. Let's see. Let's go back to heating again. So we're in manual mode. I turned the circuit breaker off. I have to turn it back on. The circuit breaker is on the back side. So now we're searching, it's going down. And there's your power. Up and down, up and down. That power was at reduced voltage. I control the voltage to the machine differently. So now we're at 220 volts input. So we'll do it again. Okay, one thing I have, because we have so many different coils, 4 different coils, each one has a different characteristic. So I'll try to get this a little more accurate, but I'm at 50%, but this thing won't go any higher. That's maximum power right now. Turn it off. I can adjust it somewhat. Oh, okay, then when you go over to the heat station, we have a switch. There's a switch on the back side. Okay, the large coil, the 100 millimeter, we use switch position number 3. And then for the 90 millimeter coil, we use switch position number 2. I'll mark the coils accordingly. And then for the 80 and the 60 millimeter coils, we use switch position number 1. And I have to emphasize, especially for the 60 millimeter coil, only use switch position 1, because the power will be too high if you for the 60 millimeter coil. Power will be too high if you go to switch position number 2. Now, what does the switch do? Well, what the switch does is that it changes the voltage at the heating coil, which is over here. For the 100 millimeter coil, you need a very large voltage, because look at all the turns. So you need larger voltage to compensate for the voltage loss in the number of turns. You got, I don't know, 8 turns, 9 turns here. That's the reasoning behind it. And this is something new for this for 2021. Previously, I just had one setting. Basically, it used to be just position 1, and I used that for all the different coils. But what happened was the larger coils didn't have enough heating power. Well, now they have more heating power because you can change the voltage to a higher level, again, to compensate for the losses. What else did I need to tell you? Oh, yes, sir. Okay. Now, then we can use the probe, magnetic probe. I already calibrated it, but I'll show you how I do it. So we go to X factor. Okay, the probe can be damaged because it has a wire has a small transformer inside here. So what I've designed is we set the power down to 85 volts. How do we know we're at 85 volts? Well, 85 volts will show up here. And then we leave it there. So that is the voltage that we'll do our testing at. And then there's a calculation in the software, and it multiplies the 85 volts times 3, which gives you the magnetic field. Were you at the full 250 volts DC? So, and here's another thing. Now you have to remember to change your frequency when you're measuring inductance. So if you know what the frequency is, then you just enter it in. In the case of the 100 millimeter coil, it runs at 180 kilohertz, so the closest number was 175, so that's what I put in there. So anyway, I turn this knob down to close to what I think is 85 volts, and then we'll leave it there after we do a test. Okay, so we take, and the timed heat is, timed heat starts when it indicates that you're heating, and it goes for 10 seconds. So I'm just going to change the power until we get 85 volts here. Right there, see it? Can you zoom in? And then I'll turn it off. All right. This is going to be a hard one to show both. I don't know how I'm going to do this. All right, this is good enough. So I have the probe here. I'm going to wait until I get the 85 volts, and then I'm going to stick the probe in the center of the coil. And then you get a measurement. So I'm waiting now. I'm going to wait for 85. Right there. Okay, now I'll stick it in the center. And there's your measurement. I'll pull it out. I'll push it back in. Pull it out. And then you stop it. You can stop at any time. So that's how that works. So there's your 478. I don't know. It's not that accurate, but it's pretty accurate. Let me see. And then when you're finished, you push the button. And that's in Gauss, by the way, and that's peak. That's not RMS, it's peak. Okay? That's how you control the system. And I'll tell you what, I'll turn the water off. And I'll change the coil. I'll go back to the 60 millimeter. Okay, make sure you turn the water off first. You want to be super safe. Turn the circuit breaker off on the back. Should show you what I'm doing here. Now I'm changing coils all the time, so I only use 2 nuts, but it's better if you use 4. Now we'll go back to the 60 millimeter coil. You see this? Put this in. Oh, one thing. Don't forget. See, I almost forgot. Now we're going to go back to 60 millimeter. So we have to change the switch back. That could be a real problem. There. Okay, now we're back in switch position number 1. And you'll see that that light turns on. There's no way for the machine to tell you that you've put it in the right position. So you have to remember. If I left it in position 3, very, 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 very high. We'll go back to X factor. We want to change the frequency. We push that, and we go back to 400. If we're going to do another test. Yeah. All right. And the light comes back on. See? So now you go back to the screen. We did the timer. And then we, for the smaller one, we go to frequency 1. And let's see what we can do here. System okay, heat is off. We're in manual mode. So, now this one, okay. Oh, see, I had the breaker off, so now I'll put the breaker back on. Okay, the breaker's back on. By the way, if you wanted more power, you have to go to three-phase power, but you don't have three-phase in your lab, I guess. It has to be three-phase 220. So this system was set up, or this system was changed back to single-phase because you can plug it into your wall socket. But at three-phase, you get about 20–30% more heating power at the same voltage. I prefer three-phase. Most of my machines are three-phase. All right, so breaker's on, up, frequency 1. Switch number 1, remember that. Switch number 1, frequency 1. Okay, so we're going to heat. You see it comes up real fast because we locked in closer to the starting point. Now I have two scopes here. One is two oscilloscopes. One is in the background, and that's just a reference. It's not very accurate. And then I use my traditional scope right here, which is excellent. And I'll show you how the frequency lock works. The square wave is the gate frequency that triggers the transistors. And then the sine wave is the actual current. And when they match, that's where you get frequency lock. So watch this. So see, there's the, and then it matches just like that. And that was a very difficult circuit to design. In fact, I had one company that wanted me to sell them the circuit. I didn't. All right, so I'm going to do some more. I'm under a lot of pressure to ship this machine. I'll get the power up a little bit higher. It's being restricted somewhat. The other thing, as I mentioned earlier, 24 volts indication. When you're heating, you get this indication. So we turn it off, boom, like that. Let's take a little tour around the unit. First, let's look at the bottom board. If I can get in there. And there's two wires I still have to connect. That's the two white wires are for the temperature sensor. But when I start heating, you get a big blue light. See that? That indicates that the bottom board is outputting voltage to the middle board. Okay, so where's the middle board? We come around. It's a little bit complicated here. You can see the green lights, and in the center there's a red light. The red light indicates that you've got DC voltage from the middle board, from the bottom board. The DC goes to the middle board, okay? And then you have four orange lights which are not very visible here. There's one, but there are 4 of them. When I turn the heating off, the green lights stay on and the orange lights turn off. The orange lights are that's an indication that your 4 gate circuits are working properly. The green light is okay. You have 4 transistors that produce the heat. Sorry. You have 4 transistors that produce the heat, okay? They're mounted on the bottom of the middle board. Each transistor has its own separate power supply. Each power supply has a green LED. So that's what the purpose of the green LED is. It shows that the power supply is running. And then you got the top board, and I have literature that I provided in the instruction manual, and it shows what all the LEDs are on the top board. I even have this switch here. I use that for testing. I can bypass the touchscreen and control power directly. Okay. All right, let's go to the back. This is the back of the unit, obviously. Okay, this is the circuit breaker that I was talking about. That controls the high power. We'll say it's the high power for heating, okay? That's all it does. This is your main disconnect switch. When you turn that switch to off, then you've disconnected all of it. And you've disconnected the incoming power. So that's a safety issue. Then you got your pressure gauge here. Then you have your water inlet, your water outlet. I marked the pressure gauge, but you can go a little higher, it doesn't matter. Then over on the right side, well, down here you have connection for 24 volts. Some people have a infrared camera for measuring temperature, so they could get their power off this to run the camera. I just provide the connection. The connector you can buy from any electronics store. Okay, the magnetic field probe, this is connected right here. And then right above it, I pull this cover off. Let me see. Right above it is the fiber optic temperature sensor system input. And I don't have it connected now because I already ran the test. But you just plug it in, and then you can use the fiber optic temperature sensor to measure your nanoparticles. You have two hoses here that go out to the heat station. Then your main cable is in here, that goes out to the heat station. Let's see if we can get a view of the switch. Let's move this. So there's your switch on the back side. All right, I've shown you pretty much everything I can think of. If there's anything else, I'll send it as an email separately. I'm very busy. I am very busy. So, okay, when you don't want to use the machine, obviously you just turn that. You can take the key out, and you can flip the circuit breaker on the back side down. I can't think of anything else to tell you. The system seems to me simple, but it's not. And that's all I can tell you. I mean, it's simple to operate, and I've tried to make the software as simple as possible, but the electronics are complicated. And they had to be designed from scratch. I don't know how you translate that into Chinese, but there is no training manual on these type of machines. I will say one thing, which might be interesting. We have a new system. Yeah, I have a new system. We're going to, I don't know if you can see it. This is the new hand unit. It can be added to this at some later date, and it would connect through this hole here. Let me see if you can. Now, of course, the hand unit is going to have a cover, obviously, and it's going to have its own heating coil. The purpose of the hand unit, think of it this way. The purpose of the hand unit is all the research that's being done is on animals. And what is the limitation on the research? Well, the limitation is the biggest animal that you can fit and treat with a heating coil is the one that can fit inside the diameter of the coil. So right now we have a 100 millimeter coil. So that's good for a rabbit, rat, small dog. But that's not a human, okay? But there's a lot of cancer. And the cancer needs to be treated in humans. So you can't put humans in a round heating coil. You can barely put an arm or a leg in a heating coil. So the idea of this, with a proper coil, is you can apply the energy directly to the surface of the person. Like breast cancer, for example, which would be the most obvious. You could apply the heating directly to the surface. Not with a round coil, per se. It would be with a flat coil. They're called planar coils. So that is something that could be an option to this machine. And I've already sold a machine such as that. And it comes with you have to add a switch to the side of the cabinet. So you can either go to the heat station or you can go to the hand unit, whichever one you want. Again, the hand unit is something I'm really been interested in. I've already built a couple, but it wasn't for cancer treatment, but they work. This thing works really well. But it's not easy to build. That's all I can tell you. I think that's everything that I can think of. So I have a few other things to do today. Actually this morning, because I have to pack this machine up and ship it to Chicago. So I'm going to turn the recording off. And of course, I am always available by email, sometimes by a Zoom meeting. So I hope you're satisfied finally with the machine. I'm going to turn it off.